In this project, we're going to create a basic 3D printable container fully modeled with joints, as well as go over the thread tool in depth. Start a new design and create a sketch on the bottom plane. Create a circle with a diameter of 75 millimeters. From here, we're going to go to the Modify tab and click Change Parameters. Parameters are essentially parametric dimensions that we can use in Fusion. All dimensions within our model are saved here, and we can edit any of them that we want, but we can also create our own dimensions within here. It's hard to explain, but it will become more useful later on. Select this plus button, and for the name, we're going to make a new parameter called thickness. Make sure the unit is in millimeters, and for the expression, this is our actual value. Set the expression to be 7.5. Press OK, and then press OK to exit the parameters. Now go to Offset. Click on the Offset tool, select our circle, and then type in thickness. You'll see that it pops up and you can click on it, or press Enter. Press OK for the offset. You will see that it now added our offset in, which is 7.5 millimeters. Finish the sketch, and then go back to the Modify menu, and go back to the Change Parameters menu. Add a new parameter called height. Make sure the unit is in millimeters, and for the expression, make it 100. Select OK. Now, we're going to go extrude this. We're going to extrude these two profiles down the thickness that we just created. So put a negative sign and then type thickness. Press OK. You will see that it will extrude this downwards. Press OK and go back in and turn on that sketch. We're now going to extrude this outer section up the height that we just wanted. The height is 100 mil. So we're going to type into the thickness, or we're going to type in height, and it should be a join operation. Press OK. Now that we just created this cylinder, we're going to use the new component tool, click it to From Bodies, and select this body. For the name, we're going to name it Container Lower. We can now see that it took our body from the Bodies folder and made a new component with it. Now we're going to chamfer the inner and outer edges. And we're going to select for the chamfer 5 millimeters. You'll see the inner edge and the outer edge are both chamfered now. Now we're going to create the lid. Create a new sketch on top of the container. We're now going to create an offset. We want to create a circle that is in between the inner and outer edge for a lid. If you look on your water bottle, for example, that's screw-on, it needs to be in between, the threads need to be in between the outer and inner edges. Now, we could get it close, but to get it perfect, we're going to type thickness. If it's on the outside, just add a minus sign. Thickness, and then we're going to add the slash symbol or divided, and then we're going to type 2. That is just going to take our thickness, which is 7.5 millimeters, and it's going to divide it by 2, making a perfect circle around the inside. Press OK. Press Finish Sketch, and we're going to extrude this intersection up 15 millimeters. Make sure that it's a join operation. Now we're going to go back and make sure our overall design is activated. We're going to make sure that most recent, actually you don't need to make sure that sketch is on. extrude and click on this outer edge and tap on the upper edge. Make sure the operation is new component. Now you're going to select the inner component and turn its visibility off. Create a new sketch on the top of this face and finish the sketch. Now we're going to extrude this up our thickness, which is 7.5 millimeters, as a join command. We're now going to chamfer the top 5 millimeters. Now you can turn on the visibility and you'll see that we have our basic shape done. Now we want to have better visibility within our container to add the threads. Go to Inspect and add a section analysis. Click on the side of the origin. Press OK. You will now see that our two components are two different colors, and you can see their shapes cut in half almost. If we want to turn this off, we can turn this off in the Analysis button, or the Analysis folder. We can now see how our lid will fit, except we have to add some degree of tolerance if we want our 3D print to fit. If we want to 3D print this. Tolerance is basically accounting for the 3D printer's inaccuracy. If it's exact tolerance, it will never fit. Turn off the visibility of the cap. Actually, make sure these are named properly. If it didn't name it when you created the if you didn't name it when you created the component, go ahead and name it now. So name it container and then container lid, or just lid. Turn off the visibility of the lid, and we're going to use the offset tool using the press pull command. Click on the press pull tool within the modify tab and click on this edge. Type in 0.5. Normally it is going to press pull out 0.5, so add a negative sign. Press OK. Now you can select. Now it's time to add the threads. So we're going to turn off the section analysis, and we're going to go to the Create tab and go to the Thread tool. The Thread tool has several different parameters that we use to design our threads. Click on the Model option to have Fusion model our threads for us. The default thread type is isometric, which is really the main thread class we are going to use. The next option we have is our size. This is also known as our pitch diameter, and is the diameter of our threads, which is the middle point between the low and high points of the thread. Set the size to be 85 millimeters. There's also the designation. This tells us the total distance the threads will go in one full revolution. Right now, it will go one full revolution every 6 millimeters. Right now, the normal 85 millimeter designation size is 6 millimeters. We're going to set it to 4. This means that every 4 millimeters in height, the thread is going to go one full 360. Now we have to remember this number because this will come in handy later. We will also select this face to start our threads. You will see Fusion will naturally model them. If we press OK, we can now see them in depth. Now every 4 millimeters, the threads will go one full revolution upwards. We're going to go back in and we're going to edit our threads. We're going to change it from full length to partial. We're going to make it go all the way down 15 millimeters, but for the top edge, we're going to drag it down, and we're only going to drag it down a little bit, 2 millimeters. but make sure the rest of the threads go down. So the offset should be 2 millimeters and the length should be 13. By selecting partial length or not full length, we can basically designate how far we want the threads to go down. Press OK to finish this. We're now going to add a chamfer to the top of our threads at a distance of 4 millimeters. So go to the chamfer, click on the top edge and type 4. This is now going to round the top off and makes it easier to thread. Now we're going to add the threads to the inner part of the lid. Turn on the lid and off the container. We're now going to select Threads again within the Create tab. On the inner edge, make sure the size is 84. Or actually, no, it's 85. Make sure it's 85. And make sure the designation is 4 millimeters. And make sure it is fully modeled. Once you do this, if we press on the other container in the section analysis, we will see that our threads are perfectly threaded together. We are now going to add joints to our lid that allow us to unscrew it within Fusion. Turn off your section analysis and select As Built Joint. We are now going to select a cylindrical joint. This joint is just a slider joint and a revolute joint combined. We're going to select the container and the lid, and for the snap, we're going to select this inner snap on top of the lid. We're going to select the slider axis, and we're going to select a minimum and maximum joint position. For the maximum, we're going to set it to 50. Now, it's actually moving the wrong part, so we're going to select the opposite. As you can see, if you do the preview motion, we don't want our lid to go into the container. We want it to go above the container. So, we're going to select a minimum. We're going to make this minimum -50 and the maximum 0. You might have to mess around with that just to get it to work, or to get the motion limits to work. But in Fusion, this is all we need to do. Now, click OK. We can see, since our main container is grounded to the parent body, that only our lid will move. We can also see that we can rotate this upper lid. It's hard to see because it's a cylinder on top, but if you turn off your container, you can see it rotate from below. Press 0, and then click on the visibility of the normal container. Now I'm also going to turn on my analysis for this because it makes it easier to see. One new tool that we're going to learn is the Motion Link joint. Go to the Assemble tab and go down to the Motion Link tool. Motion Link allows you to connect the relationships between two different joints. Click on the joint we just created and click Link with Same Joint. Since our cylindrical joint is technically a slider and a revolute, we are going to connect it to itself. Now, if you think back to our treads, we know that every 4 millimeters that the treads go up, they basically go around a full 360. This means for every 360 degrees of our cylindrical joint, the slider joint should be going 4 millimeters. What the Motion Link does is it means that every 4 millimeters the slider joint moves, the revolute joint is going to move 360. So, if we select 4 for the distance in millimeters and 360 degrees as the angle and have it animate, we will see that the treads will perfectly mesh together. Click OK. This means that if we drag it out slowly, like this, we will see that it will always stay meshed within Fusion. It's hard to see by dragging it. It might be easier to just select on the revolute. So you can see how it's actually rotating. but it is perfectly meshing, which is exactly what we want to see. Now, press 0 and then turn off the analysis. Now we're going to create some essentially grip to the upper section. Also turn off the relationship view, so we can get rid of this icon. You're going to make a new sketch on this top profile. Now we want to add little grips to the outer edges, so we're going to project the outer section of the cylinder. We're going to create a construction line going to this upper edge. Make sure it's a construction line. We're going to make a circle with a diameter of 5 on that line. We are now going to extrude this down to the bottom of the lid. You can just tap the bottom of the lid and it will go down that exact distance. Actually, that's slightly too big, and we can see that it's slightly too big because it is cutting into the threads. So we are going to go back in and make this 4 millimeters. And we can see that it is not cutting into the lid. We are now going to add a fillet to these edges with a radius of 1 to make it rounded. We're going to select the circular pattern feature within the build tab, change the object type to features, and select this extrude and this fillet. For the axis, select this outer edge or this outer circle as the edge. Now we're going to type in different values until we see what we want. I personally like 30. I'm going to select the compute type to adjust, and I'm going to press OK. Now Fusion is going to replicate that all around the top lid. If you wanted, you could also add that to the container. Now we're going to assign it a texture. My favorite texture is the ABS texture, the ABS default plastic texture. And now our container is done. And as you can see, we can unscrew it within Fusion, and it will perfectly match those threads that we created. This design is also ready for 3D printing because we accounted for the tolerances originally by doing that offset. That's it for this project. This project really added everything in, or this project really connected all of the different joints that you should know, as well as the different component relationships. So if you understand everything in this tutorial, then you are set for future videos.